Hello there, everybody. Welcome to another thrilling installment of Chemistry from Professor Stable's Basement. And so now we're going to start getting into some deeper detail on some of the functional groups. In this lecture, we're going to focus in on alcohols and ethers. We're also going to look at thiols and amines. Alcohols and ethers are functional groups which are essentially derived from water. And so we've looked at this before, that one of the ways we can depict water with its chemical formula H2O is we can also depict that as HOH. Now, if we picture one of these H's to be replaced by something for a carbon group. And so if one of those H's is replaced by, and again, remember, our groups could be anything for another carbon chain there. If one of those H's is replaced by something for a carbon group, that's an alcohol. If both of those are replaced by carbon groups, they might be identical groups, they might not. But if both are replaced, that's an ether. And we see a couple examples of those here. Here we have this, what we can picture as the hydrogen on this side has been replaced by a butane. So here's a butane compound right here, hooked to an OH. And we're going to talk about the naming in a minute, but this would get the name 1-butanol. That's an alcohol. Here we have an example where, again, if it was water, this would be H here and H here, but instead we're replaced by two ethyl groups. So here's an ethyl group attached to the oxygen molecule, and here's another ethyl group attached to the other side of this oxygen atom. So this is an ether. Both of these molecule types have a bent shape around the oxygen atom, so that bent Vesper shape of water is maintained in ethers and alcohols. Again, the only difference is we don't have hydrogens there. It's something else for other groups. It is important to note that hydrogen remember, water is definitely capable of hydrogen bonding, and that leads to a lot of the different properties that water has. Alcohols can also participate in hydrogen bonding because they still maintain that OH. Ethers, however, do not have that hydrogen still attached there. So ethers are not capable of hydrogen bonding in the same way that alcohols and water is. We do divide alcohols into three different groups, either primary, secondary, or tertiary alcohols. In order to decide what you really have to look at is the carbon that's attached to your alcohol group. And sometimes, by the way, alcohol groups are called hydroxyl groups. So you may hear me use that terminology. And so we look here at this carbon that's attached to our hydroxyl. If that carbon only has one other R group attached to it and two hydrogens, that's a primary alcohol. If that hydroxyl carbon has two R groups attached and one hydrogen, that's a secondary alcohol. If now that hydroxyl carbon has 1, 2, 3 R groups attached and no hydrogens, it's a tertiary alcohol. Let's just look at a couple quick examples of that. And so if we have something like this compound here, this is a primary alcohol because our hydroxyl carbon, our carbon that's attached to our hydrogen or attached to our alcohol group, is only attached to one other carbon. So that's a primary alcohol. Here we have a secondary alcohol, and we could make these chains whatever we wanted to over here. It doesn't really matter. But this is a secondary alcohol because the carbon that our alcohol is attached to, the carbon that's attached to our hydroxyl group, is attached to two other carbon groups, making that a secondary alcohol. We could also have something like this, where now, again, these could be anything for carbon groups here. But now our hydroxyl carbon, remember this is a carbon right here, this is a vertex. So this hydroxyl carbon here is attached to 1, 2, 3 different R groups, making this a tertiary alcohol. So let's look at our rules for naming alcohols. Just like all of our naming rules that we've talked about so far, first thing that we want to do is assign our root. So what is our longest carbon chain? We assign the ending OL for an alcohol. If the chain does have more than 2 carbons, we assign a locator number, just like we've done before. Only now that locator number is going to be used to identify which carbon has our hydroxyl group. You also want to always assign, and then we assign a prefix, just like we've done before. We assign a prefix if there are other alkyl substituents on the main chain. And here we will always assign numbering, so the alcohol group will get the lowest number. A couple examples here. So here we have this compound here. Again, we count for our longest carbon chain, 1, 2, 3, 4, 5, 6. So hex for our root. It's all single bond, so hexane. We kind of drop the E off there though, so we get hexanol. Our hydroxyl group is attached to the second carbon, so 2-hexanol. Now we have one with another substituent, but it's the same idea. We're going to count 1, 2, 3, 4, 5, 6, 7. So we get heptanol. Now we need to look at our numbering a little bit though. And we see that, like we've looked at before, we could number this from left to right or from right to left. In either way, we would get numbers of 3, 5, but we're going to choose our numbering to go from right to left because that gets our alcohol group to have the lowest number. So now that alcohol group is attached to 1, 2, 3. It's attached to carbon 3. So we get 3-heptanol. And now we see we have a methyl group here at carbon 4, 5. So 5-methyl, 3-heptanol. Again, remember also that there is that naming organic compounds handout. And so right now we're looking at alcohols. And so this is the same information that we just went over, but lots of different examples to look at. I highly encourage you to look at these examples and make sure that you are able to come up with those same names. Alcohols are found all through nature and biochemistry. Alcohols that have 2 hydroxyl groups are called diols. 3 hydroxyl groups are called triols. And with lots of different hydroxyl groups, we would call those polyols. Glucose, so the simple sugar glucose, is a polyol. Lots of different hydroxyl groups hanging off a glucose molecule. And so that glucose is considered an alcohol because of that. Let's just look real quick at naming diols. It would be the same exact sort of convention, only we would use the term diol. So let's say we had maybe this compound here, got an OH here, maybe an OH here. So again, we would number our carbons. We would go say 1, 2, 3, 4. That's going to get us our lowest numbering with the alcohols. So 4, so it's going to be butane. 2 alcohols attached though, so we would get the name butanediol. Those alcohols are attached at the 1 and the 2 position. So 1, 2, butanediol. Phenols are a special class of alcohols, and they're different enough that we do give them their own naming. Oh, sorry, screensaver started to show up. A phenol, remember when we talked about benzene, that special 6-carbon aromatic ring? A phenol, now we're going to replace one of the hydrogens on that aromatic ring with an alcohol. And so it would simply look, I'm not sure why I don't have a drawing of it here on my slide, so I guess I do on the next lecture. That's okay, or the next slide. But we would have our simple benzene ring, and then we have an OH hanging off it. That is called a phenol. Phenols can easily lose that hydrogen from the hydroxyl group. They can easily go from this form to this form here. losing that H plus from it. Remember, back to our acids and bases. What does that make phenol? Absolutely could make phenol an acid because it can easily donate that hydrogen, that H plus, to something else. That means that they do have incredible antioxidant properties, which isn't something that we're going to go into too much in this course, but just something to be aware of. When you're naming phenols, the root of it is phenol. So here's again, there's the same drawing that I had. In foods like vanilla and eugenol, which is the primary ingredient in cloves, can add a lot of flavor and aroma to different foods. Phenol is used, different phenols are used in different disinfectants. They're used to denature proteins. We'll talk about that when we start talking about proteins in a couple of weeks. But denaturing essentially means just breaking down a protein and breaking it up. And different phenols are great at that. The antioxidant capability that we talked about, vitamin E has different phenols in it. It's able to capture free radicals, which are incredibly reactive. And so that's something that can be good for us. And so we see here, again, just some of the phenols in nature and industry. So we can see this phenol here. Here's our benzene ring with our OH. This is eugenol, found in cloves. We change it just a little bit. And that's vanillin, just found in vanilla beans. So very fragrant. And again, to name phenols, we use the same rules that we use for naming aromatic hydrocarbons. Only now, instead of using the word benzene, we use the word phenol. The carbon that is bonded to the hydroxyl group is labeled number 1, and then we name everything else to get a lower number. And so again, we see here's our benzene ring with our alcohol. So this is a phenol. It has an ethyl group coming off of it. And it's we call this the 1 position attached to the hydroxyl group. And we number in such a way to get our lower number. So that would make this 3-ethyl phenol. Next, ethers. So like I talked about in like I talked about in the beginning, ethers, now we have carbon groups hanging off both sides of the oxygens. Ethers are very unreactive, and so they're quite often used as solvents. Smaller ethers were used as anesthetics since about the 1800s. Some of the first anesthetics that were used in surgeries, especially like in field hospitals in the military, ethers were a very popular anesthetic to use. We name ethers, and we're going to talk about this in the very next slide, but we name ethers as if they're substituted alkanes. In other words, the way that we would name an ether is we would call this our main chain here, and then we name this as a substituent group of that. So here we see an example here. We're going to first assign the root. We're going to look for our longest carbon chain. So in this case, that's this chain right here. So we ignore the ether part of it for now, and we look at just the longest chain. Then we're going to assign our ending based on our different hydrocarbon rules. And so this is just propane right here. If there were a double bond here, then we would name that 2-propene. And we'll talk about that. Well, actually, we won't get into that numbering that much for this class. We won't go that deep. But just know that that's what we would do. Is if there were double or triple bonds in there, we would name accordingly to with the rules that we've already talked about. Now we assign a prefix. And so the ether part of the molecule is named as if it is a substituent. And so what you need to do is identify what is coming off the other side of the oxygen. So here's our main chain. So there's our propane. Here's the oxygen. Then we identify what's coming off this other side here, and we use the appropriate prefix for that. So there's a 1 carbon group coming off this oxygen, so that gets the meth name. Then we add oxy. So that makes this what we call a methoxy substituent. And so here's the meth, and the oxy simply means that it's attached to an oxygen. So that puts the full name of this together as methoxypropane. Again, here's our main chain, 1, 2, 3 carbons long, and then attached to a methoxy. Now the numbering, when we're numbering our main chain, that does get a little bit different from our hydrocarbon rules. We number the main chain as coming off of the oxygen. So no matter what. So again, if there were, that's why I called this, if there were a double bond here, that would be 2 propene, because that's how we would number it coming off of that oxygen. Okay, sorry about that. I had to pause the video and take a look because something about that didn't feel right, even as I was saying it. And so I'll come back to that. If there are other double bonds or something else going on in the molecule, we'll look at some other examples of that. But I was wrong about that. We do name those just as we name any sort of alkene. So we'll take a look at that in just a second. But another rule is that when the main chain does have 3 or more carbons, we need to assign a locator number indicating the location of the alkoxy substituent, so indicating where the ether is coming off. And so this sort of gets at what I was just saying too. So here, we've got this compound here. And what we want to do is first identify our main chain. I know this starts getting a little bit messy, but bear with me. So our main chain right here is butane. Here's our longest carbon chain, longest just continual carbon chain. So that's butane right here. And then what we need to do is identify our substituent. Sorry about that. Our substituent is an ethoxy group. It's made up of 2 carbons. And now we can see that off our main butane chain here, it's coming off the 2nd carbon in the chain. And so that leads us to 2-ethoxy butane. Now let's go back to what I was saying before. Let's say that this is possibly an alkene that we have. What we do want to do there is name the alkene according to just the rules that we've talked about. And so let's say that we have, we'll just try to make something up off the top of my head. We have this compound here, and then let's say we have maybe this right here. And so we can see, we look through to find our main chain, and our main chain is right here. And it has 1, 2, 3, 4, 5 carbons in it. And so it's going to be pentene. We see that it is 1,2-pentene because our double bonds after our 2nd carbon. So 2-pentene. Now we're going to name our substituent. And so this is an ethoxy group. And we see that it's coming off 1, 2, 3, 4, the 4th carbon from our main chain. And so it is 4-ethoxy 2-pentene. Now, hopefully you're saying to yourself, but Mr. Staples, oh, sorry, did I not? I really apologize. I don't think I went over to this. So let's go back through that again. I'm really sorry about that. Let's just start right over. So this was the compound that I had. We identify, sorry, I'm a little off kilter this afternoon. I might have actually switched over, but in case I didn't, we'll just run through the whole thing again, because there was a part that hopefully you caught that I didn't do. So again, here's our main chain. So it's going to get pent. It's an alkene, so we get ene. Our double bond is after our 2nd carbon, so 2-pentene. The part that I forgot is that we have to assign cis or trans. And so to help us with that, if we put our H here and our H here, we kind of look at our plane down the line here, we can see that our important groups are opposite each other. And so this would be a trans compound. That's going to go in the very beginning later. So we're going to save that off to the side. Then we have our substituent group here is an ethoxy because it has 1, 2 carbons. And that's attached at the 1, 2, 3, 4th spot on our main chain. And so we get 4-ethoxy in the beginning. And then we do have to identify that it is a trans configuration around our double bond. So trans 4-ethoxy 2-pentene. One of the things I hope that you're starting to note is that, yes, if you looked at this, picture yourselves at the very beginning of this course. If you looked at a name like that, you would have gone, oh my God, what the heck is that? And yes, you're seeing that it is complicated, but it's not that bad. There, especially when you consider all the rules that we are going by. There's a system to it. Again, just going back, remembering that I do have all these examples here with the ethers. I encourage you to look through those and make sure that you're able to come up with and find these same names. I'm not going to spend much time with thiols. Essentially, thiols, the naming conventions are the exact same as they are with alcohols, only now our ending is thiol instead of ol. The difference is that instead of an oxygen, it's a sulfur atom. There are lots of different simple thiols out there. You can see some examples here. Propanethiol, 1-propanethiol, and 2-propanethiol. Thiols are found all over the place in nature and in industry. Very strong odors. The odors associated with cheddar cheese, really strong cheddar, and garlic are thiols. Onions, especially the onions that have a lot of 1-propanethiol, that's what causes our eyes to water. Skunk spray is 3-methyl, 1-butanethiol, which we can see right here. Ethane thiol is what's added to natural gas. If you smell that sulfur smell coming out of a gas tank, that's ethyl thiol that's added to it so that we can actually detect that because natural gas itself is odorless. And just different places that we find thiols in nature. It's in the amino acid cysteine. We'll be talking about amino acids in a couple of weeks. It's in an anti-hypertension drug called captopril. We can find thiol functional groups there. Brings us to our last functional group for this lecture, our amines. Amines, similar just the way that alcohols are derived from water, amines are derived from ammonia. And so NH3, we start replacing some of those H's with different R groups. And so a primary amine has 1 R group and then NH2. Secondary amines would have 2 R groups, NH. Tertiary amines would have 3 R groups, all coming off nitrogens. Since they're all derived from ammonia, they'll have that same basic tetrahedral shape. That's all we really need to talk about there. Naming. So some more naming rules. Same as we've talked about before, we assign the root based on our longest carbon structure. We assign the endings for amines, get the name amine. And then we attach a locator number to indicate which carbon on the main chain contains our bond to the nitrogen atom. And then a prefix accordingly, depending on what else we have on the molecule. So here we have a couple of different butanamines. So again, 1, 2, 3, 4 carbons long. And in this one, our amine is attached to the first carbon, so it's 1-butanamine and 2-butanamine, because our amine is attached to our second our second carbon right here. Same thing, if we had other substituents hanging off, we would still name that in the same way. Let's say we have maybe this compound here, NH2, and we have maybe a little methyl group hanging off right there. So we would identify our longest carbon chain, 1, 2, 3, 4, 5. So we're going to get the name pentanamine, because it's derived from an alkane. So we get pentanamine. We see that our nitrogen atom is attached to our second carbon. So this is going to be 2-pentanamine. And here on our third carbon, we have a methyl group. So the full name, 3-methyl-2-pentanamine. Now, sometimes we might have Actually, let's do that out again. Maybe the same thing. But now we might have another substituent coming off the nitrogen. When that happens, we simply add that as another substituent, but we put our locator number as an N for that. And so here we have butanamine. So our 2-butanamine that we saw before. But now instead of just being NH, this is now a secondary amine. So it has another R group coming off. That R group is an ethyl. And so we say N-ethyl to indicate that this ethyl group is coming off the nitrogen. And then 2-butanamine. Here, we also have 2-butanamine. So it's our same butane right here with our amine group coming off our second carbon in the butane. So 2-butanamine. But now we also have an ethyl and a methyl coming off our tertiary amine here. So we get N-ethyl, N-methyl butanamine. It's a lot. Oh, sorry. Okay. I'm not going to show that in that last slide. That's more of the same that we've talked about. And so again, remember, same handout. There are some of our rules for amines as well. Use this handout as pretty much your Bible as you're doing a lot of these different namings that we've talked about. There's lots of different rules to keep straight. They're all right here to help you. And so I know this has been a long video. Your brains are probably fried, but the only way to get good at this is practice, practice, practice. Practice your naming. You can find lots of those different resources, remember, on the website. We've got some naming hydrocarbons here in the hydrocarbons materials. If you go to the functional group materials, I believe I've got, there we go. Yep. Some practice just with naming various alcohols, ethers, and amines. So naming these various compounds. The key attached right to it. So practice these. That's the only way you're going to get good at them. So there we go. And so that is all for today's video. I hope you've enjoyed watching as much as I've enjoyed presenting it to you. I apologize that it is long, but there's a lot of material here. So that being said, you stay classy, USM.